Alright, hello and welcome to the channel. It's the last video of this sequence of integration by parts. The link to a playlist which contains all the videos on this topic is in the description down below. And let's directly dive into our integral. A couple of words on how I approached this problem. The first thing that came to my mind was to use the substitution u is equal to arc tangent of x, but it didn't give me a lot since du will be in this case 1 over 1 plus x squared dx. And well, now the problem appears because we don't know how to replace this integral so that it's expressed only in terms of u. 1 over 1 plus x squared creates some troubles. Now because of this, naturally the substitution u is equal to arctangent of x squared wouldn't work as well, since the u in this case will be just 2 times arctangent of x times 1 over 1 minus x, 1 plus x squared. Now here we can have something actually, but still, like I was thinking maybe in the next step we can use integration by parts, and I thought okay, maybe directly we can use integration by parts here. And for this I've considered, well, naturally we can consider of course x and arctangent of x squared, but first I thought maybe we can use something like x times arctangent of x square and dx, as well as the x times like this and this separately, or x times arctangent of x and arctangent of x. Like here, x times arctangent of x and arctangent of x dx, but in a couple of seconds I thought okay, it won't give a result. So combining this substitution method of arctangent of x and integration by parts that I've tried to use, so considering these two failures, some idea came to my mind to use integration by parts, but taking arctangent x squared. So I did that and realized that it leads to some good results, and thinking on the way, each time it gave me some positive results. So finally I got the result. Now let me share this with you. So as I said, I'll use integration by parts where I'll take u as arctangent of x squared. In this case du will be 2 times arctangent of x times 1 over 1 plus x squared, which is a derivative of arctangent of x. Like it's the derivative of a composite function which has the following form. We first write 2 times f of x times f prime of x. In this case 1 over 1 plus x squared being the derivative of arctangent of x. Alright, and then in this case dv would be x dx, and v in this case will have the form of x squared over 2. Now keeping all that in mind, and also for the hint, let me write that we want the form of uv minus v times du, integral of v times du, and let's proceed. So our integral is equal to, we just write uv, which is x squared over 2 times arctangent of x squared, and we subtract an integral of x squared over 2 times 2 times arctangent of x times 1 over 1 plus x squared, and dx. I forgot to write dx here. Yeah, now it's correct. And alright, at this point I also thought that perhaps we can make it to x times arctangent of x squared, so that in the end we can add this integral to both sides, like to cancel this one out and right here too. But shortly I realized it's not a good idea and went with a calm path, which was we have x squared times arctangent of x square over 2 minus, now 2's they cancel out each other, and we are left with an integral of x squared over 1 plus x squared times arctangent of x and dx. Now here at this point, of course, the natural idea that came to my mind, and perhaps to many of yours, is to make a substitution, because we already have a structure of 1 plus x squared. So if we make the substitution of u is equal to arctangent of x, we wouldn't have any problems with expressing dx in terms of du, right? Since we already have dx over 1 plus x squared. So at this point we can make the substitution, and let's just copy this one. Okay, now the substitution will be as follows. We write u is equal to arctangent of x, and in this case du will be dx over 1 plus x squared. Great, now our integral will turn into what? First we have arctangent of x, which is u, then dx over 1 plus x squared, which is just du, And then we also have x squared, and x squared in our case is, like, since u is arctangent of x, then tangent of u will be x, right? Take tangent of both sides, and you got it. So we also have tangent of u here. Here I already felt pretty good, since I thought, okay, with tangent we can deal in some way, so we are almost done. So the whole process I was going on here was kind of right. Now here we have, okay, let's write it in a neater form. It's u times tangent of u du. Sorry, it's x squared here. So x is tangent of u, so it's tangent square of u. Right. Because I did the same mistake when I was solving this on my own, and got stuck with an integral of u of tangent of u times tangent of u, which is not that easy to solve. But if you have tangent square of u, we can now express this in terms of secant, right? Since 1 plus tangent square is secant square, and it plays a vital role in our integration processes. So we just duplicate this one again. And as for the integral of u times tangent square of u, I'll write just u times, as I said earlier, it's 1 minus secant square of u, right? Du. Here, I'll just write it that 1 plus tangent square of u is equal to secant square of u. Okay, here, without too much hesitation, we can write this as u minus u times secant square of u du, right? And from now on, we are left with one integral that we need to solve, since, of course, we can separate these, like integral of u du plus, since these are like minuses, an integral of u times secant square of u du. I'll do so. So the integral of u times du is just u square over 2. Now we have minus minus, which is plus, an integral of u times secant square of u du. So now if we evaluate this integral, we are done. And why I wanted secant square of u? Because it allows us to use integration by parts, since secant square of u, we know that it's a derivative of tangent of u, right? And we can make use of it. So we have this in our hands, minus u square over 2. I'll replace u with x's in the end. Plus, now using integration by parts, I've already shown you the u dv notation. Now let's follow the tradition of this channel and use our method of evaluating integration by parts in our minds. So the u will be the function we'll differentiate later on, and secant square of u du is the function we need to find an antiderivative of. First, we just rewrite u and multiply this by the antiderivative of the secant square of u, which is tangent of u. Then we subtract what we found as an antiderivative, which is tangent of u, and multiply this by the derivative of u. In our case, it will be 1 times du, which is just du. Right, I hope everything is clear at this point. Alright, now we are actually done, since the only thing that's left is to find the integral of tangent of u and replace all u's with x's, since initially our function. Okay, now the integral of tangent of u is ln of secant of u. It's a table value that you need to remember. There is a derivation, perhaps I'll make a video on how to compute the integral of tangent of u, but for now we can just know that it's ln of secant of u. It's given in lots of textbooks, etc. And add some constant c in the end, since we are dealing with indefinite integrals. Okay, now all left is to replace these u's with x's, since initially our functions are dependent on x's. So, tangent of u is x. The tangent of u is equal to x. Now what else do we need? U itself, right? And u is arctangent of x. Yeah, also we have secant of u here. Well, we can compute it right here, that if first you can use this to see that the secant of u will be just square root of 1 plus tangent square of u, which is in our case square root of 1 plus x squared. But to make it beneficial, so that you know some other techniques, let's find the secant of u in another way, which is, imagine a right triangle. Here we know that the tangent of u is x. So we have an angle u, right? And we know that its tangent is x, say it's x and 1, right? In this case, tangent of u is x. Now, in this case, the hypotenuse will be 1 plus x squared, secant of u, which is by definition 1 over cosine of u, is square root of 1 plus x squared, since the cosine of u is 1 over square root of 1 plus x squared. Great, now we have our final answer. Since it's a final answer, I'll rewrite this expression. It's arctangent of x squared over 2 minus u was arctangent of x, so arctangent of x squared over 2 plus, now u is arctangent of x times tangent of u was x minus, now alright, here we can write this as ln of square root of 1 plus x squared and add constant in the end. So this is already our final answer, but let's rewrite this in a pretty way. Alright, before releasing this video, I've checked, of course, if my integral was correct using Wolfram Alpha, and the result was that it was not. I made a mistake here, and I didn't want to record this video again, so I've decided to go here and just correct it. Perhaps some of you spotted this in an earlier stage when I made this mistake, and even maybe without watching it till the end made a comment, so thank you. And where the mistake was, it was here, right here in this transition. Well, I wrote correctly that 1 plus tangent square is secant square of u, but what I didn't apply correctly was that in this case the tangent square of u would be secant square of u minus 1, whereas I wrote 1 minus secant square of u, right? So this was the mistake. Now let's correct it. Well, I won't write secant square of u minus 1. Instead, I can just replace this sign with a plus, right? Since it's also equal to minus 1 minus secant square of u. Now I'll do so. Let's go step by step and correct the mistake. So here we have plus, right? At this point we have plus. Then here we also have plus. Then it means that here we have plus, where this is a minus. Also, at these two places we have pluses, right? And here we have a minus, and we have a plus, minus, plus, right? Let's see, like imagine this being as follows. We'd have minus here, so minus plus. Yeah, and I think it's okay after this point. Here we have plus, tangent, minus, and plus in the end. So it seems fine. Now let's rewrite this in a more neat way. So we just rewrite arctangent of x squared, arc x squared times x squared plus 1 over 2. Then we subtract x times arctangent of x, and we can write this as it's 1 plus x squared to the power of 1 over 2, and it goes out of the logarithm. So we can write this as ln of 1 plus x squared over 2. In fact, we could also write it here, right? Yeah, but anyways, plus c. So this is our final answer. I'll rectangle it. So if you have any questions, you are very welcome to ask them in the comment section below. Here is the brief overview of what we did. And see you on the next videos. Bye.